Let's take an example to clarify things. So there's a water tank, and this water tank is sealed, and if this is sealed, and let's say the pressure here is P, and we make a small hole, very small hole, through which water is coming out with a velocity v, and the velocity v, and the density is rho, and this is pressure P. The height or the depth below which the hole has been made is h. So the question is, what is the velocity v here of the water or the liquid that is coming out? So we know from Bernoulli's theorem that half rho v square plus rho gh plus p is a constant. Okay, so if that is true, let's write this equation on top, or at least on the bottom first. At the bottom, what is rho v square? It's just rho v square. That's the variable we have been given. Plus rho gh is again the rho gh. And what is the pressure? Well, let's call pressure P naught, because we know here pressure is because of atmospheric pressure. Let's say the whole thing is put in atmosphere. So P naught, where P naught is atmospheric pressure. How about the top? So this is going to be the same because this is a constant. At the top, we'll write the same equation as half rho v square, but there is no rho gh term now, because rho gh term, the h is 0 at the top. And let's say the water is really filled up to the top with this high pressure P here. So let's make it clear actually. H should have been clarified. This is H actually. Water is up to here. This is H. Okay, this is H. All right. Plus height right here. So right here, this is what we get. And right here, we write it like this. Plus what is rho gh? 0 plus P. Now we can simplify this a little bit, and we see that at the top there's a huge area. This area is very huge, and this area is very small. So if this area is very small, then the velocity by which the whole water is going down should be a very small number. So v here, or let's call this speed or velocity, whatever you want to call this, speed is very low. So if that is true, we can sort of ignore this term in comparison to p, because p is large and this is small compared to that. So we can say p equals half rho v square plus rho gh plus p naught. So that gives us v equals, we get P minus P naught minus rho gh, and the whole thing multiplied by 2, and the whole thing divided by g, square root of that. So this is the velocity. Okay, let's take some special cases. If P is same as P naught, which means that the pressure here is same as atmospheric pressure, which means that, let's say the vessel is open. The vessel is not closed, instead the vessel is open. Then we know V is going to be square root of I think I made a mistake here. This should be rho here, and similarly it should be rho here. So that gives us square root of 2gh. You see, this is the same as the velocity of free fall. The object just falls freely. This is the velocity we get after height h. Also, if P is very high, then we can ignore any other term compared to p, and v becomes 2p divided by rho. So anything in comparison to p naught or rho gs, both are small. So they become very small in comparison to p, and that's what we can write as velocity. So velocity just depends on the pressure, capital P.